In the case of unsymmetrical alkenes, when reacted with HBr, it was theoretically said that the product which will be obtained is a mixture of haloalkanes. It means there will be formation of, that is CH3, CHBr, CH3, that is secondary alkyl bromide. And also there will be formation of CH3, CH2, CH2Br, that is 1 degree alkyl bromide. So it was theoretically said that when unsymmetrical alkene will be reacted with HBr or halogen acid, then there will be formation of mixture of product will takes place, in which there will be 2 degree alkyl halide will be also possible and 1 degree alkyl halide will also be possible. Later the scientist came whose name was Markovnikov, and he given the Markovnikov rule. According to Markovnikov rule, when unsymmetrical reagent, example HX, HOX, H2O or some other reagent which are unsymmetrical reacted with unsymmetrical alkene, then the negative part of this reagent will attack on the carbon which is having less hydrogen. It means the nucleophilic part of this reagent will attack on the carbon which is having less hydrogen. So according to the Markovnikov rule, the reaction was taking place by the help of carbocation formation. So what will happen? CH3, CH double bond CH2. In this case, there is two conditions by which alkyl bromide can be formed when the reaction is taken place by the halogen acid, that is HBr. What will be happening in this case? First of all, you know that the electrophile will attack because of the partial positive charge on the hydrogen and partial negative charge on the bromine. And this H plus ion will attack on this double bond. So there will be formation of CH3, CH, CH3, and this is a secondary carbocation. So if electrophile will attack on this first carbon of the alkene, then there will be secondary carbocation will be formed, whereas if this HBr, that is this electrophile, that is H plus, if attack on the second carbon of this alkene, then there will be formation of this 1 degree carbocation will takes place. So on the basis of the carbocation, further nucleophile will attack. The nucleophilic part is Br minus. So what will happen further? There will be formation of 2 degree alkyl halide will takes place. So in this case, there is a 2 degree alkyl bromide is forming, whereas in this case there is a formation of 1 degree alkyl bromide is taking place, that is 1 degree alkyl bromide. So on the basis of stability of carbocation, the major composition will be of 2 degree alkyl bromide, not of 1 degree alkyl bromide. So according to the Markovnikov rule, it means this Br minus is attacking on the carbon which is having less hydrogen. So stability of this 2 degree alkyl halide will be more. Because of that, the general reaction which is given by this Markovnikov rule was CH3, CH double bond CH2 in the presence of HBr, and this reaction is occurring either in the dark or in the absence of peroxide or absence of light. So there will be formation of CH3, CH, CH3, Br will takes place. This is 2 degree alkyl bromide. If the reaction of unsymmetrical alkene with HBr is taking place in the presence of peroxide, then this reaction is known as Anti Markovnikov rule. It is also known as Kharasch effect, and it is also named as peroxide effect because of there is a presence of peroxide. peroxide effect. In this case, there will be free radical mechanism will be taking place. It means in this case the reactive intermediate is free radical, whereas in the Markovnikov rule there was reactive intermediate, that is carbocation. So what will be the free radical mechanism? There are three steps in free radical mechanism. First is initiation, second is propagation, and third is termination. So let's see by the help of example how the reaction will take place. Example: CH3 CH CH2 in the presence of HBr, peroxide C6H5CO ka whole twice, this is benzoyl peroxide. There will be formation of CH3 CH2 CH2Br. So this is 1 degree alkyl bromide. Whereas in the Markovnikov rule there is maximum probability of formation of 2 degree alkyl bromide takes place because of the stability of carbocation. So what will be the mechanism of this reaction? This is general reaction. So the mechanism of reaction will be given in 3 steps. First step, initiation. In initiation there will be generation of free radical will takes place first of all. So the generation of free radical will takes place by the help of this benzoyl peroxide. So what will happen? C6H5 C double bond O O. This is peroxide bond. This bond is very weak. Because of that there will be homolytic fission will takes place. This O single bond O in benzoyl peroxide is known as peroxide bond. This bond is highly weak because O single bond O, that is the bond between oxygen. If there is a single bond between oxygen and oxygen, then this bond will be highly unstable. So because of that this bond is highly unstable, due to which there will be homolytic fission will take place. It means both the oxygen will take away the single electron of the shared pair, due to which there will be formation of 2 molecules of C6H5 C double bond O O odd electron. Odd electron in this oxygen is highly unstable because oxygen is second most electronegative element in the periodic table. Because of that the carbon and phenyl bond will homolytic fuse. Because of that there will be homolytic fission will takes place in the bond between phenyl and carbon, due to which there will be formation of 2 phenyl free radical will takes place and removal of 2 CO2 molecule will takes place. So this phenyl free radical C6H5 will attack on hydrogen of HBr. Because of that there will be homolytic fission will takes place, due to which this hydrogen will shift to phenyl. So there will be formation of benzene will takes place and removal of Br free radical, which is responsible for the chain reaction, that is propagation. So the second step will be propagation. In propagation, this unsymmetrical alkene CH3 CH double bond CH2 will react with this Br free radical. This Br free radical will react with this unsymmetrical alkene. So what will happen? This will initiate the homolytic fission of this pi bond. Because of that there will be odd electron will be coming on both the carbon, due to which what will happen? CH3 CH free radical CH2 Br will form. So in this case secondary alkyl bromide free radical is forming. This is the first step. In the second step, this secondary alkyl halide free radical will react with another molecule of HBr. So it will attack on this hydrogen. Because of that there will be homolytic fission between the hydrogen bromine bond, due to which there will be formation of CH3 CH2 CH2 Br and generation of Br free radical will takes place. Because of that this reaction will be chain reaction. So this reaction will not stop till all the free radicals which are generated in the propagation are not terminated. So in this case the alkyl halide which is obtained is 1 degree alkyl bromide. Third step is termination of free radical mechanism. All the free radicals which are generated in the propagation are terminated in termination. Otherwise, the reaction will continue to occur. There will be a chain reaction. So, to stop the chain reaction, we have to terminate all the free radicals which are generated in the propagation. So, what will happen? There are how many free radicals which are generated in the propagation? That is Br free radical and 2-degree alkyl bromide free radical. So, what will happen in this case? With every possible combination, these free radical will terminate. So, there will be formation of Br2 will takes place. This is the first possible combining of the free radical. Second, there will be formation of Br free radical with CH3, CH, that is secondary alkyl halide free radical. Vicinal dihalide will be formed. This is vicinal dihalide. In this, the adjacent carbon bromine is attached. Third, these 2-degree alkyl halide free radical will combine with itself. So, there will be formation of 2 molecule of CH3, CH, CH2, Br will combine with itself. So, there will be formation of CH3, CH, CH, CH2, Br, CH3, CH2, Br will takes place. Next question, which is generally asked in the case of Anti Markovnikov rule, that is why Anti Markovnikov rule only takes place in the presence of reagent, that is HBr, not in the presence of other halogen acid. It is because of the propagation step. So, what will happen in this case? So, in the propagation step, there are 2 steps which we have studied in the earlier mechanism, which is when CH3, CH, that is unsymmetrical alkene, is attacked by the Br free radical. So, there is a formation of CH3, CH2 Br and secondary alkyl halide free radical. The step of the reaction is this secondary alkyl halide free radical will again attack the molecule of HBr. So, it will abstract this hydrogen as a free radical. So, there will be homolytic fission will takes place between HBr, due to which there will be formation of CH3, CH2, CH2 Br, that is 1-degree alkyl bromide. And generation of Br free radical will takes place. So, only HBr is showing Anti Markovnikov rule. It is because of the 2 step. In the case of HBr, both first and second step are exothermic. Both first and second steps are exothermic, and you know that whenever the reaction is taking place by the release of energy, it means the product is more stable in comparison to reactant. So, in this case, in the case of HBr, in the both the step, that is first and second, there is energy release is taking place. It means both the steps are exothermic, due to which in the presence of HBr, this reaction is feasible. That is, free radical mechanism with HBr is feasible, whereas in the case of HCl or HF, whereas in the case of HCl and HF, first step is exothermic, whereas second step is endothermic. So, why first step is exothermic? It means the first step is feasible, but the second step of the reaction is not feasible. Because of that, there is endothermic reaction. It means the energy is absorbed during the product formation. So, what is happening in the first case? Because in the first case, there is either fluorine free radical will be available or chlorine free radical will be available, and you know that the electronegativity of fluorine and chlorine is much higher in comparison to bromine. Because of that, their reactivity towards the alkene will be more vigorous in comparison to bromine. Because of that, the first step of the reaction is exothermic. It means in the first step, high amount of energy will be released. Whereas in the second step, what is happening? In the second step, there will be HF or HCl is present. In the second step, there will be either HF or HCl will be present, and you know that the electronegativity of fluorine and chlorine is high. Because of that, this HF and fluorine bond, this bond is highly stable. In comparison to HBr and HI, this bond is highly stable. Because of that, this fluorine will not release, will not allow hydrogen to remove. It means there will not homolytic fission will takes place. Because of that, when this bond will not be broken, then this free radical will not attack on this hydrogen. Why it is happening? It is because of the electronegativity of this fluorine. Fluorine is more electronegative in comparison to this carbon. Carbon is less electronegative. Because of that, tendency of this carbon to attract this hydrogen will be less when this hydrogen is bonded to either fluorine or chlorine. Because of that, the second part of the reaction is not feasible in the case of HCl or HF, due to which the second step is endothermic. Whereas in the case of HI, first step is endothermic, whereas second step is exothermic. So why first step is endothermic? It means the first step is not feasible in the case of HI, because you know that in the first step there will be use of iodine free radical will takes place, and you know that the larger size of, because of the larger size of iodine, its electronegativity is least in halogen group. Because of that, the electronegativity of this iodine is less, due to which it will not attack on the pi electrons of this alkene. Because of that, there will be no generation of alkyl halide free radical will takes place, due to which the first step of reaction is not feasible, due to which the first step is endothermic. Whereas the second step is exothermic. Why the second step is exothermic? Because in the second step HI is used, and you know that the hydrogen and iodine both have different atomic size. Iodine atomic size is larger, whereas hydrogen atomic size is smaller, due to which the compatibility of both the atom is very less, due to which this bond is highly weak. So this bond is highly weak, so it will immediately homolytic phase, and this free radical will immediately attack on this hydrogen free radical, because the electronegativity of this carbon is much higher in comparison to iodine. So the holding capacity of this carbon free radical is more for hydrogen in comparison to iodine, due to which the second step of this reaction is feasible and exothermic. In the case of HCl or HF, or either in the case of HI, Anti Markovnikov rule is not taking place, because one of the step of the reaction, that is propagation, is not feasible, is endothermic. Only in the case of HBr, Anti Markovnikov rule is taking place, because both the steps of propagations are feasible, that is exothermic. Next chemical property of alkene is addition of element of hypohalous acid, that is HOX. This reaction is also known as Halohydrin reaction. It means in this there will be formation of Halohydrin will takes place. So let's see by the help of example. In this case, Cl2 react with water and there will be formation of HOCl and HCl will takes place. This is hypochlorous acid. So what will happen? This hypochlorous acid will react with alkene. This is symmetrical alkene. So what will happen? This is unsymmetrical reagent. There will be electronegativity difference between both the atoms of the reagent. So what will happen? This chlorine will be having partial positive charge, whereas oxygen OH will be having partial negative charge. Why OH is having partial negative charge? Because oxygen is second most electronegative and electronegativity of chlorine is less than oxygen, due to which OH will be having partial negative charge. So what will happen in this case? There will be formation of CH2, CH2, Cl and OH. This is Halohydrin. What will be its nomenclature? Numbering will be given from this OH because this is main principal functional group. So 1, 2, 2 chloroethanol. common name will be, it will be named as ethylene chlorohydrin. So before starting the mechanism of this reaction, first of all, what will be the order of reactivity of hypohalous acid? It will be given as Cl2 in the presence of H2O, Br2 in the presence of H2O, I2 in the presence of H2. This is order of reactivity of hypohalous acid. It means most reactive hypohalous acid will be formed by chlorine when reacted with water. So there will be formation of HOCl will takes place. It means most reactive hypohalous acid is HOCl. So what will be happening in this case? In this case, if unsymmetrical alkene is present, then the reaction will takes place by the help of Markovnikov rule. It means the negative part of the unsymmetrical reagent will attack on the carbon which is having less hydrogen. So what will be the reaction? If there is unsymmetrical alkene, CH double bond CH2 in the presence of HOCl, there will be formation of CH3 CH. So negative part is OH minus, so partial negative charge is coming on this OH and partial positive charge is coming on the this chlorine. So what will be happening? First of all, there will be attack of electrophile. So there will be formation of CH3, CH, CH2, Cl, and the carbocation will be on the second carbon. So it means the second carbon is having positive charge, due to which this nucleophile, that is OH minus, will attack on the second carbon. So there will be formation of this compound will takes place. So according to the Markovnikov rule, this reaction is occurring by the help of Markovnikov addition, and according to the Markovnikov rule, the carbon which is having less number of hydrogen, only on that carbon nucleophile will attack. This will be most stable. So what will be the name of this compound? IUPAC name of this compound is according to the principal functional group, which is OH. So what will be the numbering? 1, 2, 3, 1-chloropropionol. This is 1-chloropropionol. So what will be the mechanism behind this reaction? The mechanism behind this reaction is occurring by the help of cyclic transition state, cyclic halonium ion. In this, cyclic halonium ion is formed. So what will be the mechanism of this reaction? First of all, CH3 CH, that is unsymmetrical alkene, will react with the chlorine molecule. We know that chlorine molecule is non-polar, but because of the presence of pi electron, this molecule will get polarized, due to which what will happen? There will be partial positive charge on this chlorine, partial negative charge on this chlorine, due to which first of all electrophile will attack. So there will be CH3 CH formed. So what will be happening in this case? The second carbon will be having positive charge, and chlorine atom which is present at the first carbon is having lone pair of electron. So it will donate its lone pair of electron to this second carbon which is electron deficient, due to which there will be formation of cyclic transition state, that is cyclic chloronium ion will takes place, and positive charge will come on this chlorine and two lone pairs will be left. Okay. In the next step of this reaction, this water molecule will attack on this cyclic transition state, but the attack of this water molecule will not occur from the front side, because in the front side there is chlorine and there will be repulsion between water molecule and chlorine, because in the oxygen there is lone pair of electrons are present, and also in the chlorine lone pair of electrons are present, due to which there will be repulsion, due to which the front side attack is not possible. So this water molecule will attack on the back side. So the lone pair of this oxygen will attack on this carbon, that is secondary carbon, and this bond will be shifted towards this. So there will be formation of CH3 CH OH CH2 Cl. This is trans form of Halohydrin will be formed. Next chemical property is hydration, and it will occur by the addition of sulphuric acid. So there will be two ways by which hydration will takes place. In the first, indirect hydration will takes place. In this case, cold concentrated H2SO4 will be used. So what will happen? In the presence of unsymmetrical alkene H2SO4 will react with this unsymmetrical alkene. How this reaction is taking place? H2SO4 will ionize into H plus and HSO4 minus. So first of all, there will be attack of electrophile. So this reaction is occurring by the help of Markovnikov addition. So it means it is following the Markovnikov addition. There will be formation of CH3, CH, O, SO3H and CH3. This alkyl hydrogen sulfate, which was formed in the first step, will be hydrolyzed in the presence of water and heat. So there will be formation of secondary alcohol will takes place and removal of H2SO4 will takes place. So this is indirect hydration, because in this case hydrolysis is occurring in the second step. In the first step there is formation of alkyl hydrogen sulfate is taking place, and in the second step this compound is hydrolyzed. So there will be formation of 2-degree alcohol is taking place. Second is direct hydration. Generally alkene do not directly react with water, but in the case of branch alkene, example that is isobutylene. This is isobutylene. In the case of branch alkene, this can directly react with water in the presence of mineral acid, which will furnish H plus ion. This H plus ion is behaving as a catalyst, which will ionize this water molecule into H plus and OH minus. Because of that, first electrophile will attack and the second step will be of nucleophile attack. So what will be happening? This nucleophile will attack on the carbon which is having less hydrogen. Because of that, it is following Markovnikov addition. So there will be formation of, this is tertiary alcohol. It means this is tert-butyl alcohol. That is 3-degree alcohol will be formed.